I'll start. Okay. So, so if I want to duplicate, I can duplicate. For example, I want to build a staircase. Let's say Shift D. You have to select this object, right? This object is selected. Why I'm not able to move? Something happened with my mouse. Okay. Okay, there's some error. Okay, there's Blender error. Okay, if you open here, you can see. I think Shift D. I don't know what was the error. And if I Shift D, press Shift D on the keyboard, that is for duplicating, and you can move it. Okay, right? You can keep on doing that, Shift D and doing so, but you have to do in the view properly because we can move out of this. So for that you can go to view. Here you can go to the side cameras, left, right, numpad. So view, this is in your perspective view, so we can change to ortho. And then if you change to ortho, you see that there is an ortho coming here. See ortho, right? And also you see that how the Blender commands are executed, right? So then what else? If you want to go to side view, any questions?
What was the shortcut to get that console at the top again?
Which console?
The one at the top.
This is
the one that shows everything that's happening. Oh, okay.
Yeah, just try drag down. Okay.
Thank you.
See, if I want to split the screen, I can split it. Here there's a plus, right? I can split this screen. I can have two screens. I can keep splitting like this. If I want to merge this, I will have to do like this to merge. If I want to split, I can split the screen like this. Okay. Are you able to split it like this?
Yes.
Okay. So if I don't want to that, and I can merge this screen, so it is going to be one single thing. So you can keep on doing this. This is in ortho mode, right? I can view. I'm going to go to so left, right. So left side view, right side view. So front view. Okay, I want the front view actually. So this is the front view. Now I can stack this properly. I can place this, and I can place this object, and if you want, I can move this. And because perspective, sometimes you have to work in orthographic view, because in that case you can move properly the cubes. So you can do like this, right? Shift D. This is not how I want you to do. Okay, this is, I'm just showing that to build the staircase, you always use the size. Shift D again. This you place on the top of each other. So you can, then I can go to the normal default view, 3D view, right? 3D view is going to be, I don't know how it looks, 3D view. Or I can go to the view, I am going to go to perspective itself. So view perspective. And now I am in perspective view. Oh my God. So it's all, I didn't, so the view was not proper. I didn't move the cube properly. This one was fine. So you have to, this is a headache. You see, as I want to build a staircase, I am going to plague like this, so you have to be careful. So this is, it's a headache, right? To build a staircase like this, it's a headache. Don't you think so, Juko?
What I did, Professor, I just selected two objects and start copying them one over another.
But you want to write, yeah, that's right. But you better want to write a script. Is that right?
I guess so. I haven't written any scripts in Blender. I don't know how it works.
Okay, now let us.
Hopefully, it's easier.
It's not tough at all. It's very easy, to be honest. Very easy. Okay, let me just. I have my code. I wrote the code that day, so let me just write. Please learn. As I said, please do learn Blender during this. See, this I mean, to be honest, I learned by myself by looking onto YouTube tutorials and exploring myself. I just did this. Okay, so you can learn by yourself. Okay, I don't have that code for, but yeah, I think I mean, I don't want to do this way. So let's let's write a small code, okay, and in Blender. So for that you have to switch to sorry, not compositing, go to not game logic, uh, which one, scripting, okay, go to this one. So this one you'll get here, and this is the scripting window, and this is your scene, and this is your console here, okay. And are you able to get this screen?
Yes.
Yes.
Okay, very good. Now let us try to place the cube along a sine wave, right? So let me write that code for you. So see, initially you have to import BPY. So if I want to zoom in, I can press shift and I don't know how, let me just, no, it's very small, right? Okay, control plus, I think I can zoom, I can make it bigger. I don't know how to make it bigger. So it's very small here, very small. I forgot the command to make it bigger. I hope you can see this.
If you hold control and then your scroll wheel, it'll zoom in.
Oh, okay, yeah, now I got it. Thank you. Yeah, I was trying to do this, I was not able to do. Okay, I'm enlarging it for you. So import BPY. So that is the Blender Python, and from random is that package. So from random package import rand int. So this is a random to generate random numbers. From math package I want import sine, right? And now I want to see, now I will write the code for I. You have to write the code in this way, okay? For I in range, this is how you write for loop. How many of you know Python already here?
I do.
Yes.
Okay, if Python means it is very easy for you. So for I in range 50, okay, enter. So when you press enter, it will not go to the, this is automatically, you don't have the braces, closing and opening braces, right? Which we normally have in C language and other stuff to indicate that this section of code belongs to the for or if statement, right? So here only indentation is there. So indentation is very important. So this is kind of weird also for me. For x, y, z, I'm initializing. You cannot initialize in C or Java like this. X, y, z is equals to 0, okay, and I, okay, the I value, and this will be the sign of I. So basically I'm going in the YZ direction. So what is YZ? If I look here, perspective, so y-axis is this one. You can see on the corner here, right? So this is the y-axis and z-axis. I'm going to generate the sine of the cube in this yz plane. So y and z, okay, sine of I. Okay, so let me write yz plane sine of I. Then see, if you don't know the command, let's say if you don't know what is the command, you can say, you can right click this window, shift A, and let me add a cube. Okay, cube, I mean, I don't want that cube. Let's say I want to add a monkey head. Okay, monkey head. So shift add monkey head. That is called a Suzanne. So if you go to the top, you can see what the command was executed. So this was the command that was executed to add the monkey head. So I can select this, right click. So right click to select this. This is how I started coding in Blender. Because the code that I can see what is being executed, I can copy and paste this one, right? So BPY, and radius is radius of this monkey. So several things we don't need it, so we can just make it as, we need location, but other thing we can remove. So location we need it, so we can keep it as such, okay. And remove radius, we can change the radius, we can play with the radius, and location we need it. And then finally we can close everything, and other things are not needed. So these are the default thing which is not needed, so it's all false. We can delete all the stuff, okay. And now if I go back, so this is going to be, see, okay, control, okay, control, I'm going to minimize this, and this is not 4.5 because this should be x, y, z. So x, y, and z. So you're going to generate 50 monkey heads or 60 Susan, I don't know how to pronounce Susan. So 60 Susan you're going to generate, right? bpy.ops, this one. Let us run this script. If it's successful, we'll see the monkey head in the YZ plane. Okay. Can you see this?
How did you execute the code one more time?
Oh, so, okay. Run script or Alt P, I think. Okay. Alt P is to execute the code. So run script. See, this is going to keep on adding the things to the scene. Okay. So I can make the radius of the monkey head to be 0.5. Maybe it's too big. I can also scale it. You know, scale in different directions. I can. So, you know, basically it has generated again and again. So you need to clear the screen every time we run the script, right? Because for that you can use this command bpy, but that's also going to delete the camera. Remember that it's going to delete everything from the screen. So bpy.ops, that is the operations. Okay, ops stands for the operations object. Okay, select all. See, select all also, if I select this, let's say this cube, select this command is command should come here. It's a monkey head, but this cube I'm selecting it, moving it. Transform is coming, but select. Okay, don't worry. So this is select all. Okay, you can remember this. Select underscore all action equal to select. Okay, and you are selecting all the object in the scenes, and then bpy. Let me select here. You can select all the object by Control A, right? Control A or A on the keyboard will select all this. See, this command came, right? Select all action is equal to toggle. Okay, but I am selecting. I mean this action equal to select all. So this command came here. This is toggle on and off, but I want to select all. So this is going to be the parameter to this value to this parameter. Select is now here, it is toggle, so we are not worried about toggle. But if you want to select, you can select and delete X on the keyboard, press A here and delete. But I want to do with the code, so I'll write bpy.ops dot object dot delete. Okay, so now let us run the script. So now what happens? So do you understand? I'm selecting all the objects in the scene. Okay, let me maximize. So I'm selecting all the objects in the scene. Okay, I'm deleting selected. So this is a comma, not a comma, this is a dot. Okay, so I'm selecting all the so this is a typo here, object. I'm selecting all the objects in the scene and then I'm deleting it. Okay, so this is going to, you see the camera is also going to be deleted. Because camera is somewhere located here, right? The camera is also going to be deleted. So let's run the script. You're going to get, each time you run, you're going to get, you're going to delete everything in the scene and you're going to add this monkey head along the sine wave. Okay, maybe this is not pointing to the proper direction, so you want to rotate. So if I want to, so another command is that I think Control up arrow will maximize the screen. So you can write focus on command, and Control up arrow again toggle, it is going to go back to this menu, right? If I want to write a lot of code, this window is not enough, right? So I will press Control up arrow to make it bigger and Control up arrow to go back. Okay, are you able to generate this monkey head?
Yes, and it deleted only the cubes without the monkey heads because the monkey heads loop executes after the delete command. I guess that's why.
I didn't get you, Zuko. What you're telling?
So when I execute the code, it deleted the cubes, but the monkey heads, I guess because it generates the monkey heads after it deletes all objects.
Exactly, that's why I want to delete whatever in the scene. So I want to delete everything. Then I want to add new objects in the scene. Okay, so it deleted whatever is existing and then it created the new one, right? So it will, even if you add something, Shift A, you are going to add some cube, whatever it is. Did I add or not? Shift A cube. So if I'm going to run the script, it's going to delete everything in the scene and it's going to create the new monkey head. Okay. And this is facing in the wrong direction. Maybe press R on the keyboard, N property, and R, and then you can see R on the keyboard, and try to rotate and try to face this properly. Face this. Okay. Um, so maybe I want to face in the other way. Okay. You can try this. It's why it's rotating. This it's not rotating in this direction. R on the keyboard. So this is, I want to rotate around the Z axis. Okay, I can, if you want, you can rotate here. You can direct N on the keyboard and you can rotate in the, by, what I'm doing is that I'm left mouse button, I'm scrolling it. Okay. And if I want to have 90-degree rotation, I can directly type 90 degree here. Okay. So the monkey will be facing in like they will be facing, all other monkey heads are facing in this direction. So what command I use this Euler rotation. So you can basically copy this code and then execute this. Let me try this if this works. Okay, I will copy all these 3 lines and I will paste it here. And every time I think you have to make it as an active object. Okay, context is, I think you have to include one more command. It won't work. So this is not needed. So Euler 2, actually this is not needed. So this is the Z axis. Only I want this code. Let me run this code. If it doesn't work, I will see what happened. Why it doesn't work. Okay. Why there is false, 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 false? What code is this? Layers. Oh, I added this one. Okay, this is not needed. Okay. Let us run the script. Now you can see that all the monkey head are facing towards us. Okay, before they are facing in the other way. So this is generating in the sign, right? So this is interesting, right? Are you able to do this, guys?
Mine works.
Okay, for others? How about Chantida? How about Jeremiah?
Yeah, it's going pretty well.
Okay. So let us write another code. So I just told how to write, let me write another interesting code that is also looks good. So this is nested loop in this one. So for I in range, let me put, I used K in range, so whatever. So for, I do use K in range 5 or 50, whatever you want to do. I'm going to have nested loop for, this is our next program I'm writing for I in range 5, and for I in range 5. Okay, and bpy.ops.mesh. I mean, I know if you don't know, you can put that object on the scene and then see what is the command. So this is primitive cube add, and radius is equals to, radius of the cube is 0.25, and location is equals to the value of I, J, K. Okay, let us run this code. It's going to delete all the monkey head and is going to create a cube of cubes. Okay, this looks interesting, right? Are you able to get this cube of cubes? Type, I will wait. I'm not in a hurry. Okay, let me add 50 cubes. It's going to destroy all the cubes. It's going 50 is going to big. The computer is going to crash now. I hope it is going to crash. See, it's running. 50 is too much. So see why the computer becomes slow. You see the computer is fast for generating 50 cubes in the XYZ direction. I am gone. See, it's running script and I don't know whether it will work. So now you know why we need a fast computer, why we need a very fast computer, right? So your computer to generate 50 cubes, it's going to take long time to generate. It will eventually generate, but I don't know, sometimes your RAM will, if your RAM is full, then this is going to be collapsing. Okay, don't give 50. I just gave, I should not have given like that. Now I don't know how to stop the script from running. Okay, see, it's crashing. But were you able to get these cubes?
I'm almost there.
Okay, I don't know why did I put 50. Now see, my Blender is crashing, and there's no problem in the code. It's just because it's a huge number, so it cannot generate 50 cubes along the XYZ direction. So it is going to take a lot of time. Okay, maybe I'll start another Blender, see if it works in me. Maybe Blender. Okay, let me just draw another instance of Blender. Okay, then I'll go to the compositing, not compositing. Do you want to learn? I don't know. This depends upon your interest. On Thursday's class, how many of you want to? Do you know how to? How many of you use After Effects? How many of you use After Effects here in this class? Patrick Jason is not here. How many of you use After Effects here in the class?
I don't use it, but I've.
Mhm.
Isn't that expensive or what is that?
It's to add effects, like
That's
special.
an Adobe suite, right?
Yeah, Adobe.
Yeah.
It's very expensive. So I can teach you next class. Okay, next class, if you want, I can teach you how to do compositing. Compositing means having a green plate. Okay, green plate. An object is shot in front of the green plate. Then you are going to remove the green and replace with the background. So you want to know, I can teach you in the next class if you want. It depends upon your interest. If you want me to teach that, I can teach you how to do compositing. Are you interested or not? Or you want to do coding, a lot of coding? Depends upon you. Hello?
I mean, I think it'd be all right.
All right. So you will enjoy. How about others? Bitrix, do you want to learn green screen removal, green screen removal? Bitrix, Chantida?
Anyway, it's fine. I have a lot of papers, so
Okay. Okay. So others, okay, I will do compositing. Maybe I'll show you how to do the green screen, remove the green screen. Compositing I'll teach in the next class. But today's class, I don't know whether this one crashed or it's still running. See, this is still running. So I think it just RAM is gone. Okay.
Most likely crashed because I did 10 by 10 by 10 and it took it like 15 seconds to generate the pattern.
Uh-huh. Okay.
And that's way smaller number than 50 by 50 by 50.
Yes, exactly. So let me not trust that that one. So we will do here. Okay. And so let me do this. Okay. Let me. If you want to add a cube along a circle, you know how to do, right? So let us do that as well. Import. You have for every statement control. So this one is important. Import BPY should be there. Import BPY. And I'm going to select whatever the object in the screen. So BPY dot OPS dot object dot select underscore all action equal to select. Okay. let me enlarge this. Okay, this is you type this one, and then angle is equals to I times, okay, I didn't write I loop, for I in range, of, let's say 10, okay, and let me declare n is equals to 10 and radius is equal to 7, okay, for I in range 10, okay, or I can say n because I declared n, right? So I can say n. So n, I'm going to say x is equals to radius multiplied by, I will also say import math. I'm going to import all the math. You want to import specific thing, you can say from math import sign, like that you can tell, but I'm going to say import math, okay, radius multiplied by math dot cosine theta, cosine of angle, y is equals to radius times math dot sine of angle, z equals to 0, and bpy dot ops dot mesh dot primitive. I hope you are following the code. This is not a difficult, okay, except that I'm writing in Python, and we have did this code many times in the class. Location is equal to, this square bracket also does work, x, y, z, okay, square bracket, and entire code is looks like this, okay, and if I want, this is the entire code. What this is going to do is it is going to generate the cube along a circle, okay. Let me run the script. There is an error. See, if there's an error, okay, it says that look in the console. Where's the console? Go to window and toggle system console. Okay, don't close this console. This is going to close the blender. Okay, don't press the X. Toggle system console. If you want to see the error, go to window and toggle system control will close that. If I want to open, I can open this, and they say angle is not defined. Okay, angle is not defined because I didn't write what is angle. Angle is equals to I multiplied by math dot pi multiplied by 2 divided by n. Okay, I didn't delete, so it is that default cube is still there, right? I want to delete this, so bpy dot ops dot object dot delete. Okay, now run the script. So I am having the cube placed along a circle. See, you understand why we need scripting now, guys?
Yeah.
Because scripting is an automation, right? You are not placing this cube by moving here and there. So if you write the script, I can generate along a circle, right? So this type of thing is very easy. You can now you can generate I mean, I will give an assignment. You can, I don't know whether I have an assignment. Let me just go to my D drive courses Blender tutorial. I think this is the one this was done long back. Let me open this. What is happening? Nothing is there. Okay, this is the one I did for the particle simulation. Okay, so the particle sim, this is keyed particle system. So I showed you other day, right? So this all particles gather and then it drops down on the plane. So this is what I showed you in my this thing. So I did this. So you, like this, you can create all this animation, particle and forming, and this thing and this one. Okay, so I'm not going to teach that one now. because that's a long, that takes one whole class to do that. Okay, computer graphics, not in computer graphics, Blender tutorial. I don't know where I kept it, my files. Where's that? Courses, computer graphics. Should be in computer graphics assignment. No, it's not here. It's not over here. Tutorial also is not there. I don't know where I kept. I was accessing it. D drive. Okay, D drive. And I don't know where is my Blender folder. F drive. Okay, I think it's in the F drive. Okay, Blender assignments. Okay. Cube circle. Cube circle. Let me open this. I don't have that concentric circles. I want to show you something. Concentric circles. Okay, let me just see this one works or not. Concentric circles. There's some error. Console. OBJ is not defined. Why OBJ is not defined? I don't know. OBJ dot world matrix. Okay. I think 1 minute. Why there is an error? Let me just OBJ dot OBJ is equals to you don't have to do anything, just watch me doing it, because I myself don't know. I don't know whether this is working or not. I thought it's a working code, but it's not working. Active context bpy.context._active object. Let me run this. Till I'm getting an error. This one, I don't know. I have to look onto the code why I'm getting error. Let me close this one. There's too many windows open. Let me close this one. Okay. This is one you're working on that. Okay. And so this one I don't want to. Okay. I'm not sure why I'm having an error in that code. Okay. Concentric circles. Open too many windows. Okay. For toggle system console. Toggle system console. It's not. Where is the system console went? It should work. I'm not sure why it's not working. It's having some error. So I had to look onto the system console, but I'm not sure where is that. There's too many windows open. This one is not needed. Okay, quit. And okay, here it is. World matrix has no attribute. World matrix object doesn't have a vacuum. Okay, I think I'm making a lot of mistake in this code. Okay, let me not worry about this. bpy.context_. Okay, bpy.context_active object and world matrix. I don't know what I'm doing here in this code. Let me just comment this, see if it works. This is giving problem, right? Let me comment this. Comment is this one. Okay, let me comment this. Okay, now I'm getting this. Okay, I think there was an error. So can you I mean, my next assignment is that, let me compare this and this. Here the cube is also oriented, right? Do you see the difference? Cube is oriented, rotated by theta. I want you to rotate. If you don't rotate, if I put 0, you can see the difference. How would so 0? This you can do today. Okay, see the difference. Here everything is
Yeah.
not facing to the center. So this is theta. I want you to, actually I shown you the code. I want you to make maybe, don't go for too much. Let us say 10 concentric circles. It's going to crash.
Oh.
Okay. So I want you to make this. This is a part of today's in-class exercise. Think about it. Okay, the code is shown here, so don't blindly type the code, but see this. You're going to generate this concentric circles. Okay, cubes. So if someone is asking you to do manually, will you be able to do it?
Impossible.
Yeah, I can figure it out.
How? By trial and error?
Oh no, just trying to get the for loop to work properly.
Okay, you cannot place these cubes manually, right? Did you understand my question? So I'm telling that if there is a cube, this is the code, right? Let me just I will start up. See, I cannot I cannot place. Maybe I can add a circle, shift A, and a mesh circle is there, and scale that circle, and try to shift D and shift D. Okay, select this object. This object is not selected. Shift D, place here. Shift D, place here. Shift D, place here. Shift D, place here. Again,
Yeah.
you cannot keep doing this forever, right?
Yep.
So that's why we need to write script for it. Okay, and a lot of people are afraid, even the artists. That's why animation studios like Walt Disney, they need programmers, because they will do programming, because artists know how to use they can model something, right? I think I modeled even, let me just where is that? I have J1. Okay, let me see J. I don't know, let me open this. So this is like, try to model my face. Okay, this is, I can do this in Blender. Okay, model, this is my face. I'm trying to model it, my face. This artist can do this. Okay, artists can do this. But if they want to generate something um, like placing the circles, then you need to write scripting. So always, you see, this is why we should know programming. If you don't know programming, then it will be very difficult. Okay, I hope you got my point. Let me check how much more time I have. Wasted time. So please write code. So my clock is time of 24. I have half an hour more, right? So we will write some other code. So this is fine. So for your in-class assignment, can you do that concentric circle for in-class assignment? This is definitely crashing. I'm going to close that. Close the program. Okay. For your in-class assignment, I want you to, this is going to be due next tomorrow. So please see the concentric circle. This is, I want you to, so this is going to be an assignment, placing the cube or monkey head, whatever you want to place, you can place. So remove this. This is causing error, and run the script. So I want you to generate maybe five concentric circles, and you want to do this as a part of in-class exercise. Okay, so that will be due tomorrow. You can do that, right? And I need only the Python code. Don't submit the blender file.blend file. Copy this code in a text file and take a screenshot of the output and submit that individual. Okay, don't submit the .blend file, because usually the blender file is going to be saved as a .blend file. So please don't do that. Okay,
All right.
submit only the text file. Okay, so now You can also directly access the matrix, okay, matrix in Blender. So we have seen matrices in 3.js, okay. Let me just tell you the matrix, explain you how matrix works, okay. I will close this one, open a new Blender file. So I will go to compositing window, not compositing, sorry, scripting, okay. So you can write this code along with me. So import bp by from math utils package. I need a matrix, import the matrix. Then you know this is going to select all the objects in the scene and delete that. We are going to use this method, object select all, action is equal to select. See, if I want to maximize this, when I write code, I don't use this part of the interface, right? You can press control and then arrow, control arrow will make the screen bigger, okay? So now we can focus on writing the code. bpy.ops.object.delete and bpy, I'm deleting all the objects in the scene and adding mesh primitive cube add, and location is equals to 0, 0, 0, okay, and obj is equals to, so I'm selecting the cube, okay, bp by dot data dot objects, okay, because it comes with the default name cube, right? So I'm going to uh, uh, select the object with the name cube, because let me just show you, shift up arrow, sorry, control up arrow. So this object, if you want to know the name of the object, see the name of the object appears here, cube, see, right? And also if you press N on the keyboard, you can find the name of the object. The name of the object will be there. It's called, it is cube. I don't know where the name of the object is in the window, but you can see over here, it is the name of the object. Name of the object is cube.
I think it's all
Yeah,
the way
here,
in.
yeah, here it is
Yep.
cube. So that is the name of the object. So that's cube. I'm going to select that object, and I'm going to assign that to obj. Okay, now shift up arrow, control up arrow, and then I'm going to maximize the screen. Print before applying the matrix, so /n. So I'm going to display the world matrix. So obj.matrix world. Okay, this is matrix world. So for the cube, I'm describing, every object has its own matrix. Okay, let me run this code. Okay, and so I'm selecting this and running this. I'm deleting, adding the cube. Okay, then run the script. Okay, now if you go to console here, see the matrix for the cube is a 4x4 matrix. And what do you see from this matrix? What is this matrix called? Anyone?
Translation
Identity
matrix.
matrix.
Oh, it's the identity matrix.
Very, very good. It's an identity matrix. Okay, so this is an identity matrix, which means that nothing is applied, right? So now let us do this. Let me just translate this. You know, you can directly work on the matrix. So this and all, it's very difficult. You know, this codes and all. There's nothing. There's no like. If I search to like internet, complete internet, and also there is no one good book on Blender with Python coding. Okay, I searched everywhere, so it was very difficult to find a Blender book, Blender textbook with Python coding. Only they talk about the interface, how to create 3D models, how to create buildings like that. Okay, they never talk about this one. So this one I did my own research to understand this one. Okay, there's no one good book which we can follow. So I tried experimenting it and I got this. Okay, so please try to learn this. So now the matrix, let's say matrix is called as what do you want to call translation. I mean, I don't want to use, I will just TRE and trans. Okay, translation, I will use trans because I don't want to mess up with the inbuilt function. So 1 0 0 0. Okay, and there should be opening here. This is the first row of the matrix. Then there is a comma, and this will be 0 0 comma 4 comma 0 comma 0. I left a space here. Let me align properly. Okay, this is my second row in the matrix. Okay,
That comma is a period up there.
yeah, there's a comma. This is a comma, right? And 0 comma 0 comma 1 comma 5 and 0 comma 0 comma 0 comma 1. Okay, and then close this square bracket and close this matrix. Okay, now what I want to do is obj, that selected cube, it has the matrix world, we described that, is equals to applying the translation matrix. Basically it has identity matrix. I am replacing the identity matrix with my own matrix, which is a scaling and the translation matrix. Okay, so now I will copy this code and after applying the matrix, okay, and control this one, run script. I hope, okay, there's an error. So what is an error here?
You're missing the circle brackets. The front opening ones.
All right, thank you. Everything has this opening bracket. Oh. Oh. Let me run script. Okay, now we see this. We got this because we scaled in the which direction this was. We are scaled in the y-axis, so we are getting this one. It's translated. If you want to see the matrix, how the matrix will look like, toggle system console. You can see before applying the matrix is called identity matrix. After applying, we are translating in the in the z direction. Okay, z is the upward direction, and then we are also scaling it, right? If I want to scale in the x, if I want to scale in the maybe x direction also, I can scale and run this. So this is going to be this one. Why this is, for building staircase, you need to scale this, right? You can write the staircase program using this one. Okay, do you have any questions about this? Are you able to get this or not, or I am coding for myself?
I got it.
You got it? So this is fun in Blender, right? So how do you write code directly? So you you can apply all this matrix you learned, you can directly apply the matrix to the object. Okay, so now let us build the staircase. Okay, the concentric circle, please submit. We have 15 more minutes. Okay, that concentric circle, that placing cubes on the concentric circle, please submit by tomorrow. Okay, I will post this video lecture after I finish this class. I will post this in YouTube. You can watch this. Okay. Okay, so shall we go to the next part? So next one. Okay, I'm going to delete this. Okay, I'm going to import math utils. Okay, I'm going to delete all this stuff. Okay, this I don't need. I want to import math also. So I will import all the packages from math. So import math. Okay, now for I in range, this should be a colon, x comma y comma z. is equal to 2 multiplied by I. You can understand the logic later. Okay, so in the x and y I'm setting the x and z I'm setting the position, and ppy dot ops dot mesh dot primitive cube underscore add. Okay, and now I'm going to select the whatever the created object that is an active object. So that active object is assigned to the obj. So active object. So active object, the object that is selected is an active object. Okay, this is my active object in the scene. So every time the active objects is the selected object will be the active object. Okay, remember that. So active object. I'm going to apply translation is equals to 2 multiplied by I multiplied by and 2 multiplied by I, and translation matrix is equals to matrix. I can directly use like this way also. Translation I can call translation matrix. Okay, then obj dot matrix world is equals to translation matrix. Okay, so this is a I'm forming the translation. This is nothing but variable here, and then that I'm passing that variable into translation matrix and calling that as a translation matrix. And obj.matrix world is going to be assigned the translation matrix. So you can run the script. What happens? Let's see. You're going to get this staircase. Okay. Are you able to follow? Type the code and see. But this staircase doesn't look good, right? So let me combine with the previous code. So in the previous code, we scaled the matrix also, right? So we will apply scaling to that translation matrix. So we will have scale matrix. Let's text dot translation. I had to Google. Okay, I don't know whether matrix dot scale in Blender Python. So there is called matrix called scale is there. Okay, that is accepting the 2 parameters. Matrix dot scale. I don't know what is the origin scale here. So I have to read the code. Origin scale of 1 square root. Okay. Let me not worry. Let me just write the scaling matrix like this. Okay. Scaling matrix is equals to matrix multiply. I can in this you can copy. I deleted it, but you can write the code. Okay, I think I should have an bracket should be placed properly. 1 0 0 and 0. I want to scale in the y direction, and then 0 comma and then 0 0 1 0. This is I'm just coding the translation matrix. Okay, I'm only coding the scaling matrix. I only scale in the y direction. So then it is going to be 0 0 0 and 1, and then this is going to be closed, right? And then this is for the matrix. So nothing will happen in the code, and but why nothing happened? Because you have to multiply the scaling matrix and translation matrix. So let me multiply the scaling matrix with the translation matrix and then see what happens in the code. Now we are going to get this nice staircase, right? Are you able to get this?
Yes.
So you can directly manipulate with the matrix and you can get this one. Okay, so you can scale in what direction you want, and you can do with the Blender. Okay, and you can do several things. Okay, you can directly I am not very familiar with shading and all in Blender, but this is one way. Also, if you see that subdivision modifier, you can add modifier. So If you selected object, you can add modifier or whatever. So I don't know what modifier will be useful over here. Okay, I don't know. So you can, I don't think bevel, what will bevel will do? Bevel will make it more like edges going to be beveled. Okay, now I can say, I can copy this code and I can bevel, okay, obj, ppy, active object. So I think obj dot, how do I do this? So vpy dot ops dot, okay, context dot objective object, okay, vpy dot, okay, I will write obj dot, let me, I don't know whether this will work or not, I'm just trying, okay, myself. So there's an error, okay, I think, I don't know what is the error. I'm a syntax error, I know, I'm trying it for the first time, okay, so I don't know how to, where is this? Angle is not defined. This is with respect to this. I don't think this is not this code. Okay. Windows toggle system control. So object has no attribute called modifier.add. So it doesn't have an this modifier called add. Let me go back to the original code how it was. Run script. Okay, this is working fine. Okay. Are you able to see the effect beveled?
Yes.
Okay. So I just added the modifier. I just put in the code, so it is beveling every staircase. Okay. So you can do like this. You can see the only way to learn scripting is just trying with manually and seeing what command has been executed and running the script. This is how I learned scripting in Blender. Okay. Do you have any questions about this? How many minutes more? My clock is not set to the American time. So you have 10 more minutes. So how do you find Blender? Blender is easy or wrong? Difficult?
Doesn't seem too bad.
Okay. So this is very interesting. If you love coding, this is very interesting. Okay. And this staircase and all is good, you know. So, and you can add any modifier. I think I showed you how to add beveled modifier. I mean, there are so many modifiers. So who knows unless until you use that, right? So we don't know this. So we don't. But don't worry about it. Okay, I think you code this. This is also very important. Finally, we have 10 more minutes in this, right? 10 more minutes. 5 more minutes. 10 more minutes. 10 more minutes. Okay, let us write this code and see. Okay, you please save this code. I am not saving it because I have the copy of all this code. Okay, so please do save the code, because as I said, it is there is no book on Python Blender coding. Okay, whatever I am teaching in the class, that is going to be can be used as a notes to refer in the future if you have any problem with coding in Blender. Okay, because there is no book.
You scroll down just a little bit.
Okay,
Thank you.
I can make it full screen for you. So your assignment today is to place the cubes in, make 5 concentric circle, place the cubes along the 5 concentric circle as I showed you just 10 or 15 minutes back. So that will be great as a part of your uh, uh, small hands-on exercise, okay, in Blender. Please do that. Okay, I think I have this code. You can also write the code for Vogel's formula. So I'll show you the code. I don't want to write. I can show you the code. I have wrote it several times. So I don't know what Jack Rogers did. Okay, I will show what he did. This is one of the student assignment. Okay, he wrote to generate this tree. Okay, I gave us an assignment in Blender. Okay, so this is from Lockhaven. Okay, there was a student who, this is nothing but the code for if you see this is code for geometric interpretation, turtle geometry interpretation for rail system. So this was one of my student code. So he generated the branching tree like structure, okay, in Blender using the code. So this is the whole code. You know, there's a whole code he wrote, and he got it. Okay, so and I helped him. So this is the string, and this is 3D, nice 3D. You can have nice 3D tree. Okay, it's one of the assignment I gave in the previous student class. Okay, let me just I want to tell you something else. I forgot what I want to tell you. The Vogel's formula, right? I closed that. Where is that? It's in, I don't know where is that. Okay, I have to go to. Please practice Blender in the when you have a break, when you have so a lot of students, one of my student did so many good things in Blender. Okay, I taught Blender, and he designed a lot of things in Blender. Okay, and I think this is the phyllotaxis. Okay, which is the Vogel's formula, I guess. Okay, but this is one of the student assignment as well. Okay, here it is basically he generated, instead of on a plane, he generated on a 3D surface. So this is nothing but the sunflower only, right? The sunflower head, you see this, right? So this is, if you go to top, you will see that. Okay, view is equals to, or top cameras is basically view ortho, and you want to go to the top view and see how it looks like. View front, bottom, top. Okay. This is nothing but here it doesn't look here. Okay, I know why the problem is. This is not finding here. You can see the beneath. Okay, but here it forms that spiral pattern. Okay, he did in 3D. Okay, I gave him an assignment, so he wrote in Blender again the code. So this is all written in Blender. So this guy has done, and this is from a paper. Okay, implemented. I gave him a paper to implement, but what I want you to show is this one. This one you did as a part of the assignment for you, right? You did in my class. So here, this is the entire code. I can maximize this code. Okay, you can, when you have time, you can work on, see this code and write this code in Blender and generate this. Okay, so only 137.5 is going to be it's going to be, so it didn't delete. Okay, I delete manually, so it didn't delete. So run the script, so you're going to see this nice pattern. Okay, so this is the sunflower head. Okay, so now you can also write, you can also say some of these spears on the edge will become a petal. Okay, and then you get the sunflower. Is that clear? The spear on the edge, you can, if you render this spear on the edge as like a petal, okay, petal like surface, then you're going to get a sunflower. So this has been discussed in algorithmic beauty of plants. I think I'm running out of time now. I have 3 more minutes. I'll show that. Okay. Go to algorithmic beauty of plants publication. So the lady who developed this sunflower is actually, so here also you can see the sunflower, right? So it was developed back in 90. Her name is Deborah Fowler. She has her website. She's teaching Deborah Fowler. Her website itself is, she's a PhD student of my professor, Dr. Puzinkiewicz. She is also teaching math for visual effects, and I don't know where she's, some ACAD, some student examples. So she's teaching Blender and everything. She's in a visual effects department. Okay, so her name is Deborah Fowler, and she created the sunflower for her PhD back in 1990s. Okay, and she is teaching courses like procedural modeling, particles, procedural effects, everything she's teaching, only for visual effects. Okay, so I cannot teach. This is a whole course. Remember, this is a whole course. I'm teaching just you know very basic. Okay, these are all fun exercise. Okay, Deborah Fowler. Why I told Deborah Fowler is that because she was the one. Deborah Fowler was the one. If you go to the algorithmic beauty of plants, I think I click somewhere else. So if you go to model of plant organs, so not phyllotaxis. In this paper, they have described so how this arrangement is there. This is called floret arrangement. 137.5 only will get this pattern, and that can be seen in the sunflower. Okay, and some of them are so the outer edge, will differentiate into petals. You're going to get the sunflower. Okay, it's same arrangement pattern. Even these petals are arranged at 137.5. Okay, are you able to get my point? So here, instead of the balls rendering as a ball, you outer rim you have, right? This is outer rim. You find all the outer rim, so the circle in the outer rim, and you model as a petal. So then you'll get these nice petals. Okay, a sunflower basically. Here also they didn't put that spear. They have used a different kind of objects because this is some kind of like a triangle kind of object, right? That is in the sunflower. So if you can generate one shape, then you can generate sunflower, like a sunflower field, right? You can randomly generate sunflower field. So this is quite interesting, right? Okay, these all things are done using the same Vogel's formula, 137.5. Yeah, and here we have several layers, rows, and all these things are in 137.5. Okay, and they talk about why this is very important. Even pineapples, all these organs, it's 137.5 is going to be the golden angle. That's called golden angle. Golden angle, right? Have you heard of golden angle? No?
No.
Oh,
Golden angle is the 137.5. You can, the golden ratio is there. Golden ratio, golden angle. Google about that golden angle, and there's golden proportion of the face also. It's all like the ratio. That ratio is found in nature. That only they are trying to model. All right. Okay. So even this book, Algorithmic Beauty of Plants, if you see the front matter, Deborah Fowler will be acknowledged because she contributed to the chapter. Right, so with Deborah Fowler, okay, she contributed to the chapter. She's a professor in she worked in Toy Story because seeing the sunflower, she worked in few movies, Toy Story, and now she is a professor in one of the university, and she is teaching all this nice software and nice courses which is about modeling. This is very basic computer. Whatever we did in this course is very basic. Okay, we didn't go to the advanced level of computer graphics. Here also she is having this, phyllotaxis pattern generator, right? So you can this and all, even if you were even comes in movies also in that procedural modeling, Casino Royale, that the title slide will be using be scripted actually. That guy came to my professor. Okay, this is organic shapes. Okay, and it's very interesting. Okay, and coding is interesting. With this course, you see that coding is not difficult. It's interesting, right? Any suggestions for this course, guys, for future? I have one more class.
Probably do all the homework in Blender.
What
Probably.
you want to do the homework in Blender?
Oh no,
Um,
yeah, I mean that would help me a lot for
yeah,
me, but
yeah, sometimes I mean homework, yeah, whatever the assignments you did in 3.js, you can, when you during the time, you convert to Blender, because sometimes I teach Blender code only graphics using Blender, sometimes I teach only using 3.js. Okay, I alternate between those. When I last time I teach using Blender and coding, and this time I'm teaching 3.js. And this time I'm teaching for the first time in East Roseburg University. But back at Lockhaven, one time I just taught in 3.js, other time I taught in Blender. So I switch back and forth. Blender is a nice tool, okay? I will teach you compositing on next class, the final class, so which is very interesting. And how to do compositing in Blender we'll teach. That is also interesting, okay? We'll see whether you can do that. And today's class, that's it for today's class. And please play with Blender. This is an interesting tool, okay? And I will tell you about the final exam, what is going to be the final exam, whether it's going to be a programming or it is going to be theoretical, okay? And I have to give you good assignment for the final exam. You know, if it's going to be programming, I should have a good programming thing. Okay, last flower, I enjoyed giving it a flower because a lot of students had it right the way I wanted, you know, so people were understanding it properly. It was very good to know. Anyway, we'll see you on Thursday then. Okay, thank you guys for today's class.
Thank you, Professor. Have a
All
good
right,
one.
thanks.
Yeah, welcome.
See you.
Bye.
Professor, I
Mhm.
got in a little bit late. I just
Okay.
wanted to make sure I got put down for attendance.
Okay, sure. Nicholas. Okay, I got you. Thank you.
All right. Thank you, sir. You have a good night.
You too. Yeah.
I'm also here.
Freddy,
Yeah.
were you able to work on Blender today?
No, but I can write you an email and tell you like what's going on and
Yeah. Please watch all the YouTube videos. If you're coming late, watch the type. I'm going to put this in YouTube, right? Please watch those, okay?
is that where you've been putting all of your old lecture, like the on YouTube? Because I was looking for it on D2L.
Yeah, it is in D2L. All the lectures, synchronous session, I'm putting in D2L.
Okay.
Is a YouTube, okay? The YouTube channel is called as J Lectures. You can find that. You can find all the links. So today's class also I'm going to put now. After I finish the meeting, I'm going to put that. I post as an announcement in D2L, right? So check that.
Okay. All right. Thank you.
Yeah, you're welcome.